Oh,
All right.
okay.
Okay. Hi, my name is Stephanie Nee, and the insect I will be defending is Quesada gigas, or the giant one-year cicada.
Hi, my name is Ali Cypress, and the insect that I will be defending is Magicicada septendecim. Today, we will be debating on which of our two species contributes the most to the environment.
Okay, so the giant cicada, or Quesada gigas, belongs in the order Hemiptera, which are known as the true bugs. They go through simple or gradual metamorphosis, which means that their immatures look just like adults, only smaller. The giant cicada begins its life as a rice-shaped egg deposited in usually a tree branch or trunk. And once they hatch, they'll usually feed for a short time on the branch or trunk before they drop into the soil and burrow down to feed on the tree's roots. And giant cicada immatures usually stay below ground for up to 4 years, where they'll tunnel and feed on the roots. And giant cicadas are not periodical cicadas, which means their emergences are not synchronized, but the adults emerge at similar times each year. When the time comes to emerge, they emerge as nymphs and they'll climb to the nearest tree, shed their exoskeleton, and finally become adults, where they usually just live up high in the tree branches and feed on the tree sap, and they'll call for mates at the time, which is where their sound comes into play. There are over 40 species of cicada in Texas, but the giant cicada is unique in terms of its sound. It's often described resembling a steam engine or a train whistle. And giant cicadas can reallocate a large amount of nutrients by when they emerge, they'll release all their nutrients that they collected underground into the soil again, because when they die or when they get eaten, they kind of add to the food chain and they can distribute these nutrients to the soil, which helps the trees grow, the same trees that they feed on. And cicadas generally don't harm humans, even though they can be a nuisance in their large numbers and their loud mating calls. And some cultures actually consume them because they're pretty high in protein.
Okay, so Magicicada septendecim, also known as the 17-year locust, is also part of the order Hemiptera. The Syndicum species are the largest, with bodies that are about 1.5 inches long, and they have an extensive orange coloring on the underside of their abdomen. Every 17 years, they emerge from the ground in enormous numbers. The immature cicadas dig their way out of little holes, crawl up a vertical surface, split their nymphal skin, and slowly emerge as delicate white insects with red eyes and black dorsal thorax. About a week after their emergences, the male cicadas begin singing in order to attract mates. After about a month's time, a new generation of cicadas begins a secret life. After about 6 to 8 weeks, the eggs hatch within twigs, and the cicadas fall to the ground and they dig into the soil. There they will spend the next 17 years feeding from tree roots. They build a feeding chamber or tunnel 10 to 12 inches below the surface where they stick their piercing mouth parts into the roots of the trees to feed on the plant juice. As they age, they move closer to the surface, spending the last 7 to 8 years of their lives between 4 to 5 inches underground. Magicicada septendecim contribute to their environment from both underground and above ground. During their underground stages, cicadas are a favorite food for shrews and moles. When they emerge, they provide a feast for a number of bird species. They aerate the soil with their holes, return nutrients to the soil when they die, and provide a big feast for fungi who get to work on digesting their dead bodies.
Awesome. So, a question that I have for the 17-year cicada is How are researchers able to study them thoroughly when they only emerge every 17 years?
Okay, so that's a great question. So researchers study different broads of the 17-year cicada that are staggered over time, and they're all scattered across the United States, which basically means that while a particular broad may only emerge in, like, say, the upper East Coast once every 17 years, a different broad is almost certainly emerging somewhere else during most of those off years. So this is how researchers are able to thoroughly study the 17-year cicadas. So my question for the 1-year cicada is, how can your species contribute more to the environment when they emerge in a less numerous amount than the 17-year cicada?
Okay, so though they may not emerge in numbers as large as the 17-year cicadas, giant 1-year cicadas emerge more frequently. So they're constantly bringing nutrients up to the surface each year rather than every 17 years. So the giant cicada is the widest ranging species of cicada in the Western Hemisphere. While they don't emerge in such high numbers, research still links their emergences to spikes in resources, as they contain large amounts of dissolved nitrogen, phosphorus, carbon, and lipids. They are also annual cicadas, meaning that while the immatures remain underground for up to 4 years, their cycles aren't really synchronized. So adults emerge each year around the same time, usually from April to October in South Texas and between June and July in Central Texas. So they're consistently supplying the food chain by serving as prey for various predators and putting resources back into the soil and aiding in the growth of the trees on which they feed on yearly. So another question I have is, how are 17-year cicadas contributing to the environment as much if they only emerge every 17 years?
Okay, so even though they only emerge every 17 years, as I stated earlier, the 17-year period for each broad is staggered over time, and the different broads are scattered all across the country. Due to the fact that they emerge in such enormous densities, the impact of their emergences every 17 years is huge in comparison to the 1-year emergence that you see in the 1-year cicada. They lay a greater number of eggs in the trees, which is a natural pruning that results in an increased numbers of fruits in the succeeding years. And their emergences from the ground turns over large amounts of soil, and after they die, their decaying bodies contribute a mass amount of nitrogen and other nutrients to the soil. Yeah, so now on to our closing statements.
All right. So, in conclusion, I think that giant cicadas contribute more to their environment as they emerge consistently each year in decently large numbers. Giant cicadas are unique in their loud train whistle mating calls and are attributed to late summer and early autumn. Giant cicadas usually emerge yearly, so they're a constant resource contribution to their environment. And another point is that because they emerge yearly, they're above ground in the same locations each year for researchers to study. So they contribute a lot to important research in evolutionary and ecological importance. Researchers can also view them in the same areas and same months each year, and they're also very widespread, so they're not just centered in a few locations. So in conclusion, I think they contribute a lot to their environment because of the frequency that they emerge and their convenience as a research topic.
Okay, so I think that the 17-year cicada contributes more to the environment around them because when they emerge, they do so in such a mass density. After such a great number of cicadas emerge and mate, females lay their eggs in tree branches. This acts as a natural pruning that results in increased numbers of fruits in the succeeding years. Also, after a few weeks, the adult cicadas die, and their decaying bodies provide a tremendous amount of nitrogen and other nutrients to the soil. They are also an important part of the food chain, providing a nutritious meal for moles and screws. Underground and when they are above ground, they feed many different species of birds. Lastly, the 17-year cicada broads are staggered over time and they are scattered all across the United States. So this allows the cicadas to contribute to their surrounding environment on different 17-year cycles in different areas across the country.
All right, and that is our debate.